Question 4.6 says the smaller circle must be translated by k units along the x-axis to touch the larger circle internally. Calculate the possible values of k. Now, in order to calculate the possible values of k, we need to envision what the circle touching this other circle internally would look like. So that would mean it's touching it over there, and that would also mean that it's touching it over here. And although these diagrams aren't perfect, we get the idea. So we need to move it such that this part is here, and such that this other part is over there. So what we're going to do is we're going to calculate the y-intercepts of these points over here. But we don't really need to do that. We don't really need to set y to 0 because we already know what the length of the radius is. So the radius of this one would be square root 80, or square root of 180, which would be 6 root 5. So 6 root 5. So we know that 20 minus 6 root 5 will give us this point over here. And 20 minus 6 root 5 and then plus the 2 root 5 of the current radius of the smaller circle. So the smaller radius, I'm going to name it RS, which will be 2 root 5 or root of 20. And then we have R big, which is 6 root 5. Now for this circle to touch this one internally, again I said it needs to be shifted such that it's inside of the circle at that point. Therefore it will be 20 minus 6 root 5 plus 2 root 5. So this is the first value of k. So k will be 20 minus 6 root 5 plus 2 root 5, which will be 20 minus 4 root 5, which you can get in decimal format to be 11.06. Then the other k value will be equal to, similarly, we'll have 20, but in this case, instead of going in this direction, we're going in that direction. So 20 plus the radius will be 20 plus 6 root 5. And then now we subtract the radius of this other circle such that it remains within the circle. So minus 2 root 5. So that would be 20 plus 4 root 5, which will be equal to 28.94. So these are the two values of k that we can use in order for the circle to move and touch it internally.